Hello students, welcome to our YouTube channel. This is lecture 1 of our series of computer science lectures for class 11th. In this lecture 1, we are starting the chapter 1 of unit 1 of computer science for class 11th. The chapter name is Computer Fundamentals, and the topics that we are covering in this lecture are evolution of computers, earlier computing devices, Von-Neumann Architecture and Von-Neumann Bottleneck. In this lecture, we will learn the evolution of computers. We will see what triggered the invention of computing devices and how these devices evolved from time to time, which contributed to the invention of modern day computers. We will learn about various early calculating devices. We will see what these devices were and their significance, their functions, who invented these devices, and what are the important questions that are asked in our exams from these devices. We will learn about Von-Neumann Architecture and Bottleneck. We will see how Von-Neumann Architecture revolutionized the modern day computers, and even after revolutionizing the modern day computer architecture, what is the bottleneck that is associated with Von-Neumann architecture. So let's start with evolution of computers. So when we think about evolution, the first word that comes to our mind is development, and we ask what triggered the invention of calculating devices. See, when human being evolved, when the civilizations were first settled, there was no calculating devices. Men used to count on fingers or on walls. So what triggered the invention of calculating devices? So we see that need for faster and error-free calculations led to the invention of calculating devices. If we want to count a small number or add few numbers, we can do that counting on our fingers. But when trade started, things changed. Buyers and sellers felt the need of faster and error-free calculations, which pushed them to invent computing devices. From time to time, new inventions took place, which led to the evolution of computers. जब हम एवोल्यूशन ऑफ कंप्यूटर्स यानी कि कंप्यूटर्स का डेवलपमेंट कैसे हुआ, उनका विकास कैसे हुआ, इसकी बात करते हैं, तो हम देखते हैं कि अगर कोई छोटी मोटी कैलकुलेशन या काउंटिंग हो तो उसे हम इजीली कर सकते हैं अपने फिंगर्स पे, लेकिन जब कोई बड़े नंबर्स चाहिए, जब कोई बड़ा हिसाब किताब लगाना है, तो हमें किसी ना किसी डिवाइस की ज़रूरत पड़ती है. तो इसीलिए जब ट्रेड स्टार्ट हुआ, जब ह्यूमन सिविलाइजेशन सेटल हुई और ट्रेड स्टार्ट हुआ, तो ट्रेडर्स ने देखा कि भाई अगर हमें कोई छोटा मोटा सौदा करना है उसे तो हम फिंगर्स पे भी काउंट करके कर सकते हैं, लेकिन हमें कोई बड़ी काउंटिंग करनी है, बड़ा हिसाब किताब लगाना है, तो हमें उसे जल्दी भी करना होगा और उसमें एरर भी नहीं होनी चाहिए जिससे कि हमें घाटा ना हो. तो इस वजह से कंप्यूटिंग डिवाइसेस का इन्वेंशन स्टार्ट हुआ और समय समय पर इन डिवाइसेस में कुछ ना कुछ चेंजेस होते रहे, जिससे कि हम एक मॉडर्न कंप्यूटर तक पहुंचते हैं. तो इन डिवाइसेस में सबसे पहला नाम आता है एबेकस का. एबेकस वाज द फर्स्ट कंप्यूटिंग डिवाइस और कैलकुलेटिंग डिवाइस. एबेकस वाज इन्वेंटेड बाय मेसोपोटामियंस. Abacus consisted of beads and movable rods divided into two parts, and Chinese further improved abacus. See, we all know what abacus is. It is simply a device which contains some rods and beads. This is simple abacus. What is important about abacus is it was the first calculating device. It was invented by Mesopotamians. In exam, it can be asked who invented Mesopotamians, and students are even often confused whether Mesopotamians invented the abacus or Chinese invented the abacus. So the answer is Mesopotamians. Mesopotamians invented the abacus, but Chinese improved it. So whenever it will be asked who invented abacus, you should be sure that Mesopotamians invented the abacus. This is the only important thing in this slide which is related to abacus. Next is Napier's logs and bones. John Napier devised a set of numbering rods which are called Napier bones. So in this picture you can see a set of rods that are kept in the box. These logs are called Napier bones. On these logs, on these rods of wood, certain numbers are written, and multiplication and division were performed by keeping these rods along with each other. So when we keep these rods together, a kind of table is devised. This table, which is also present in the picture, and this table is known as log tables. So we see that Napier bones were invented by John Napier, and through Napier bones, John Napier gave the idea of logarithms in 1617. So the important thing related to our exam, which is asked in exam, is who gave the idea of logarithms. So you should know that John Napier gave the idea of logarithms. Logarithms, I am sure that it is present in your mathematics topics, and the idea of logarithms was given by John Napier. So we see that here the concept of multiplication and division was introduced in our devices, and we will see how it evolved and what other functions were added to these devices and how it led to the evolution. Next device is Pascaline. Pascaline is a very significant device for our study. Pascaline was invented by Blaise Pascal. Blaise Pascal was a French mathematician who invented this device. Pascaline could do addition and subtraction. Pascaline couldn't do anything else than addition and subtraction, and it had a carry transfer capability. Pascaline was made up of gears which you find in the machines, various machines, mechanical machines. So Pascaline was made up of gears and worked on clockwork principle. So what is the clockwork principle? Though it will never be asked in your exams, but I think it is important for you to understand what is clockwork principle. I'm sure most of you will have a wall clock at your house, and we see in a wall clock that the hand of second hand revolves around a center pivot, and when it completes one revolution, the minute hand shifts just a little bit. So this is the clockwork principle. In Pascaline, certain number-threaded wheels were present, and when a wheel completes one revolution, the second wheel just shifts one position. So this is the clockwork principle. Pascaline worked on clockwork principle. It was made up of gears. It could do only addition and subtraction and had the carry transfer capability. The important thing from exam perspective in this slide is who invented Pascaline and what were the capabilities of Pascaline. What could Pascaline do? Pascaline could do addition and subtraction. Did Pascaline had carry transfer capability? Yes, Pascaline had the carry transfer capability. So we see that Pascaline was a very significant device. Why? Because the mechanism for calculation, this automatic mechanism where the gears or the wheels could do some calculation, it was the development of calculating mechanism which was very significant at that point of time. So our next device is Leibniz calculator. Leibniz calculator was an extension of Pascaline. Gottfried Leibniz extended Pascaline. Gottfried Leibniz was a German scientist who extended the Pascaline because Pascaline was very popular at that time. So what Leibniz did, that he bought one Pascaline and extended it to add multiplication and division capability. So Leibniz calculator could do multiplication and division along with the addition and subtraction that Pascaline could already do. The multiplication was done using repeated addition. So this is very simple mechanism, like when we were kids and we had to recite the tables, we used this mechanism where we added one number with the previous number and form the table. So this is Leibniz calculator, and the only thing that is important in the Leibniz calculator is the operations it could perform. Leibniz calculator could perform multiplication, division, and also the basic functions of Pascaline like addition and subtraction. Also, it could be asked, how did Leibniz calculator perform multiplication? So we should know that multiplication was done using repeated addition. So we see in Leibniz calculator that our calculating devices got the capability of all the 4 arithmetic operations by using some mechanism. Next device is Jacquard's loom, and you will be wondering on what common grounds can we compare a loom with the computers. So we will see it here. Joseph Jacquard is a very important name. Joseph Jacquard devised punch cards. You can see here in the picture there are some kinds of sheets, and on these sheets there are some punched and some holes are punched. So these cards are known as punch cards. Joseph Jacquard, who was a weaver in England, devised the punch cards to automate the cotton weaving process and used them to control looms in 1801. So in 19th century, when the industrial revolution was at its peak in England, Joseph Jacquard devised a way to automate the cotton weaving process using punch cards. Punch cards were used to automate or instruct the looms about what kind of pattern they want to weave through the looms. So we see here that concept of storing and retrieving information was developed here using the punch cards. And we also see that punch cards, though it was not related to the computers, it somehow contributed to the concept of storing of instructions in our computer. Next is difference engine. Difference engine was developed by Charles Babbage. Charles Babbage, who is also known as father of the computer, modern computer, invented this machine called difference engine. What could difference engine do? Difference engine could calculate mathematical functions, polynomial evaluations, and differential equations. Since it could do differential equations, thus Charles Babbage gave the name difference engine to this machine. So what is the significance from exam perspective in this slide? It is very important that you memorize and learn these functions which were the operations of difference engine. डिफरेंस इंजन के जो ऑपरेशंस हैं ये हमारे एग्ज़ाम पर्सपेक्टिव से बहुत इम्पॉर्टेंट हैं, आपको याद रहना चाहिए. ऐसा इसलिए है क्योंकि एनालिटिकल मशीन जो कि एनालिटिकल इंजन जो कि इससे एडवांस्ड मशीन थी वो बेसिक अर्थमेटिक ऑपरेशंस करती थी, जबकि डिफरेंस इंजन जो कि पहले बना था वो मैथमेटिकल फंक्शंस, पॉलिनोमियल इवैल्यूएशंस और डिफरेंशियल इक्वेशंस इन्हें सॉल्व करता था. तो ऑफन हम कंफ्यूज हो जाते हैं, हमें लगता है कि डिफरेंस इंजन पहले बना था तो ये सिंपल काम करेगा, सिंपल ऑपरेशंस करेगा, और एनालिटिकल इंजन बाद में बना था तो ये इजी ऑपरेशंस करेगा. सो डिफरेंस इंजन इज़ इम्पॉर्टेंट टू आवर exam perspective. The next device is analytical engine. Analytical engine was designed by Charles Babbage. Analytical engine was the basis of modern computer. See, here we see it included the concept of a central processor, memory storage, input-output devices, and stored information could be modified. If we observe these concepts, we see that our modern computer which we use at our home or in computer science labs have the same things. A modern computer has a central processor, memory storage called RAM, input-output devices like keyboard, mouse and monitor, and stored information could be modified using file systems. So we see that analytical engine was the basis of modern computer, and due to this analytical engine, Charles Babbage was known as father of modern computer. See, Charles Babbage developed two machines, analytical engine and difference engine, but it is due to analytical engine that he is known as father of modern computer. Analytical engine could perform all four arithmetic operations. Four arithmetic operations means addition, subtraction, multiplication and division. It could also do comparison like greater than, less than, and on the basis of the comparison it could do decision. So here we see how starting from abacus we reach to the analytical engine. Analytical engine was never made. It is not mentioned in your books, but you should know that analytical engine was only designed and Charles Babbage died before he could develop this machine. The next machine is Mark I. Mark I is very significant and very important. Mark I is a very important device and very significant device. Mark I was first operational general purpose computer, but it is still counted in earlier calculating devices. There is a reason behind it. I will discuss it. Mark I was constructed by Professor Howard Aiken in collaboration with IBM. So it could be asked, who constructed Mark I? Mark I was constructed by Professor Howard Aiken. Mark I was an electromechanical computer which was based on Babbage's analytical engine. So everything that Charles Babbage mentioned in the design of analytical engine, Mark I had those things. But Mark I was an electromechanical computer. What does it mean? What does it mean by electromechanical computer? It means that though it consumed electricity, but it had movable parts like gears and wheels which were needed to be shifted. So we see that Mark I has both the electrical parts as well as the mechanical parts. That is why Mark I is called electromechanical computer. Mark I was first operational general purpose computer. What is a general purpose computer? I will explain, don't worry about it. Mark I could execute pre-programmed instructions automatically without any human intervention. Means we will provide some program to the Mark I and it will perform those instructions automatically. we will not need an operator, human operator, to be sitting all time with the Mark 1. See, Mark 1 was general purpose computer. It means that Mark 1 was not a specific purpose. Mark 1 could perform more than one program, many programs. What is general purpose and what is specific purpose? To give you a clear idea, you see that in your bikes or in your cars there is a speedometer which show you the speed of the vehicle. Speedometer is a specific purpose computer. It could not do anything. You can't play games with your speedometer. The only thing you can do with your speedometer is to calculate the speed. But your PC, personal computer, your laptop, your smartphone, these are general purpose computers. Means you could do various things with these computers. You can play games, you can send emails, you can do the calculations or programming on these devices. So this is the difference between a general purpose computer and specific purpose computer. Mark 1 was first operational general purpose computer. So why are we studying this general purpose computer in the earlier calculating devices? Because in the modern computers, when the generation of computers started, we only include the electronics computers. Since Mark 1 was electromechanical, it had both the electronics part as well as mechanical parts. Thus we do not include Mark 1 is in modern day computers, and we study Mark 1 in earlier computing devices. So in the evolution of computers, while reading about various early calculating devices, we learned how, starting from a single simple device made up of beads and bones, which was known as abacus, computers evolved to become more sophisticated after each invention, and now the computers have become an inseparable part of our life. Each invention, be it abacus, be it Pascaline, be it Napier bones or Leibniz calculator, contributed to the development of modern day computers. And from the earlier devices, from the devices which had the limited purpose, now we have the smartphones, laptops and supercomputers which can affect all spheres of our lives. Next topic is Von-Neumann architecture. It is very important. Von-Neumann architecture, you will be studying Von-Neumann architecture from your school till your post graduation. So let us clear Von-Neumann architecture for once and all. Concept of stored program computer was proposed by Dr. John von Neumann. See, concept of stored program computer is called Von-Neumann architecture. Simple as that. Before Von-Neumann architecture, what we used to do is, we had a computer and the operator was sitting on the computer all the time, giving instruction to the computer to perform any single operation. What does it mean? It means that if we have to add two numbers, we can't do it. The computer cannot do it. Computer did not have the capability to add the computer on its own. The human operator who was sitting with the computer will type the machine code for addition and provide two numbers, and then only the computer could do the addition. So what Dr. John von Neumann proposed in 1945 is that we will take the program and the data and store it in the memory, and then the processor will access the data and program from memory using a communication channel to execute it. So we see that in the architecture which was proposed by Dr. John von Neumann, which is known as Von-Neumann architecture, proposed a stored program computer. This computer will have the program and data in the memory, and the processor will access this data and program from memory using a communication channel, and we will not have to type the instruction and data at the time of instruction, and thus the need of a human operator to be sitting all the time with computer for every single operation will be eliminated. Thus it was a revolutionary step in the computer science, and we will see how it led to another drawback, another bottleneck in Von-Neumann bottleneck. So I hope Von-Neumann architecture is clear to you. I will explain it in Hindi so that you can understand it better. देखो, डॉक्टर जॉन वॉन न्यूमन ने 1945 में कंसेप्ट दिया स्टोर्ड प्रोग्राम कंप्यूटर का. अब जब इन्होंने ये कंसेप्ट दिया, इससे पहले तक क्या होता था कि एक कंप्यूटर होता था, उसके साथ हमेशा हर समय एक ह्यूमन ऑपरेटर बैठा रहता था, प्रोग्रामर भी जिसे हम कह सकते हैं मॉडर्न डे लैंग्वेज में. वो इंस्ट्रक्शन देता था, इंस्ट्रक्शन टाइप करता था रन टाइम पे. अगर हमें ऐड करना है तो वो मशीन लैंग्वेज में एडिशन का इंस्ट्रक्शन देगा, उसी टाइम इंस्ट्रक्शन देगा, उसी टाइम डेटा फीड करेगा और उसी टाइम रिजल्ट मिलेगा. लेकिन डॉक्टर जॉन वॉन न्यूमन ने क्या कहा कि हम एक काम करते हैं, हम प्रोग्राम और डेटा लेते हैं, उसे मेमोरी में स्टोर करा देते हैं, जिससे कि हमें बार बार टाइप नहीं करना पड़े, बार बार हमें हर एक छोटे से ऑपरेशन के लिए किसी ऑपरेटर की ज़रूरत ना पड़े. इससे हमारा टाइम बचेगा. और उस प्रोग्राम और डेटा को प्रोसेसर एक कम्युनिकेशन चैनल के थ्रू एक्सेस करेगा. मतलब कि हम एक वायर लेंगे, उससे प्रोसेसर और मेमोरी को जोड़ देंगे, जिससे कि प्रोसेसर मेमोरी में स्टोर्ड प्रोग्राम और डेटा को एक्सेस कर सकेगा और उसे एग्जीक्यूट कर सकेगा. यही था डॉक्टर जॉन वॉन न्यूमन का वॉन न्यूमन आर्किटेक्चर, और इसी को हम स्टोर्ड प्रोग्राम कंप्यूटर भी कहते हैं. तो अक्सर एग्ज़ाम्स में हमसे जो क्वेश्चन पूछा जाता है वो ये है कि हु प्रपोज द कंसेप्ट ऑफ स्टोर्ड प्रोग्राम कंप्यूटर. सो वी शुड नो, हमें पता होना चाहिए, हमें याद रहना चाहिए कि स्टोर्ड प्रोग्राम कंप्यूटर और कुछ नहीं, वॉन न्यूमन आर्किटेक्चर था, एंड इट वाज गिवन एंड प्रपोज्ड बाय डॉक्टर जॉन वॉन न्यूमन. Von-Neumann bottleneck. We see that the Von-Neumann architecture revolutionized the computing and computer science. But though it revolutionized the computer science, it also brought a bottleneck. We see that before explaining what is this bottleneck, I will ask you to look at this picture. This beautiful picture has a very weak bridge, very fragile bridge, and here is the memory which I have drawn. Here is the processor. So processor is a very fast device. It is like a highway, it is like the field on that side of the bridge. आप वहाँ पे जाके भाग सकते हो, दौड़ सकते हो, हजारों लोग एक साथ इधर से उधर भाग सकते हो. And here on this side you see the memory. Memory is also very wide. There are many programs, much data could reside in memory. And on the processor side there is seamless capabilities of processor. Many processes and a processor is capable to execute very large programs, very big programs and instructions at a very high speed. But here the bridge resembles the communication channel. This is a single bridge which resembles a single communication channel. Since you can see that though the processor side and the memory are very wide, this bridge is very narrow. So what happens is, at one time only one thing can go through this bridge. Either it will be instruction or either it will be data. Why is that so? Because memory has both the data and the instruction. Since instruction and data both are in this memory, both are on this side of the bridge. The processor at a time could access only one thing which could be data or a instruction. So it limits the capability of processor. और अगर मैं आपको एक और एग्जांपल देना चाहूँ तो आप ये देखिए कि आपके आसपास अगर कोई मकान बन रहा होगा, क्योंकि मेरे आसपास बन रहा है तो मुझे ये एग्जांपल बहुत अच्छा लगा कि एक लेबर है, वो एक साथ समथिंग अराउंड 18-20 ईंटें उठा के ले जा रहा है छत पे. वो 18 से 20 ईंटें ले जा रहा है, वो उसकी कैपेबिलिटी है, वो अपनी कैपेबिलिटी का पूरा यूज़ कर रहा है. अगर हम उससे ऐसा कहें कि भाई 18 से 20 ईंटें मत ले जा, तो एक बार आ, एक ईंट ले जा, फिर वापस जा, फिर एक बार आ, एक ईंट ले जा, फिर वापस आ, इस तरह से कर, तो उसकी तो कैपेबिलिटी का वेस्ट हुआ ना. वो तो अपनी कैपेबिलिटी का यूज़ ही नहीं कर पा रहा. यही एक तरह से वॉन न्यूमन बॉटलनेक में होता है. इन वॉन न्यूमन बॉटलनेक, since there is only one single communication channel between memory and processor, the processor at a time can fetch data or an instruction from memory. Thus we observe that single communication channel limits the throughput of processor, because using a single communication channel to access both data and instruction force the processor to work in a sequential manner. Sequential manner यानी कि यही एक बार में एक ही ऑपरेशन. This limitation of single communication channel to access both data and instruction is called Von-Neumann bottleneck. I hope now that it is clear to you what is Von-Neumann bottleneck. So our topic is complete for today, and these are some questions which I think you should know. I will advise you to write the answer in the comments. If you do not know any answer, I will anyway provide you the answers. So get tuned to the video and wait for the answers. In today's lecture, we went through certain important information based topics. There was nothing like coding in today's session. We learned certain important concepts like stored program, sequential processing, Von-Neumann bottleneck. I hope that you liked this session. If you have any doubt or query, you can mention them in the comment section, and also please do share the session with your classmates so that we can keep on studying on the regular basis. The questions in this slide are very important from your exam perspective as well as and for your own knowledge. So I would advise you to try to solve these questions, and if you won't be able to solve, if you have any kind of query or doubt, you can ask about the answer in the comment, or you can ask about these questions in our Telegram channel. The link of the Telegram channel will be provided in the description of this video. Till then, take care.